This is the number of photons emitted by the sun every second. It is so vast and unimaginably large that it is more than a billion times greater than the number of sand grains on Earth. Photons travel through the cosmos blasting Earth's surface, and it's these photons that enable us to generate solar energy so effectively. But when was it discovered? How do we generate it? And how do we connect it to our homes and the grid? I'm Thomas. Guys, welcome to another episode of Tech Dynamics. In 1839, a French physicist by the name of Edmond Becquerel observed that certain materials allow a flow of electric current when exposed to light. This discovery sparked a chain reaction that has slowly shaped our understanding of solar cells and how we can harness energy from sunlight. Solar cells are basically everywhere. We install them on our roofs, in our garden. There's even a small one in my calculator. But how do they work? I mean, there are no moving parts, no sound, and quite frankly, you don't even notice if they're working or not. Virtually all solar cells operate on the photovoltaic effect. You see, there are certain materials that kinda get really excited when exposed to sunlight. That's exactly what the photovoltaic effect is. It's the principle we use to convert sunlight into electricity. You see, when two dissimilar materials are placed close together and exposed to sunlight, a direct current and a voltage are generated. But how does it work? You see, silicon atoms have 14 electrons in total, 4 of which are in the outer shell. Together, silicon atoms share their outer electrons to have a complete outer shell, making the material much more stable. By the way, I've made a whole video dedicated to silicon and the purification and doping stages it is subjected to make silicon wafers for PV, which you can see right here. Now, in a solar cell, we modify the microstructure to either add extra electrons or have extra empty spaces. To have extra electrons, we add some phosphorus, as it has 5 electrons in its outer shell, meaning that there is a free electron to move around for every phosphorus atom added. Boron is added to do the complete opposite. You see, boron atoms have 3 electrons in their outer shell, so an empty space or hole is left behind for each boron atom. These two variations create the P and N-type silicon semiconductors. P-type is short for positive and N-type is short for negative. The place where they join is called the PN junction, and the area surrounding the junction is called the depletion region. When exposed to sunlight, photons with enough energy enter through the N-type silicon to the PN junction, knocking an electron into the N-side layer. This momentarily creates a hole, which is then filled from an electron in the P-side layer. This results in a buildup of electrons and holes in the outermost regions of the cell, creating a potential difference between 2 points, which basically is a voltage. Through an external circuit, electrons travel to fill the holes in the P-side, creating a current. The external circuit, in most cases, is represented by thin metal wires that carry electrons to complete the circuit. The thin strips are called feeders, and the thick strips in the middle are called busbars. The busbars feed into the electrical connection on the back of the module. By the way, because I'm sure that some of you are asking this, how can we control the output current and voltage of the module? Basically, it all depends on whether we connect the modules together in series or in parallel. Let's say we have 4 modules, each generating 30 volts and 6 amps of current. If we connect them in series, the voltage adds up to 120 volts, but the current stays at 6 amps. On the other hand, in parallel, we generate 30 volts and 24 amps of current. Bear in mind that both setups produce the same power output. So, in most cases, both commercial and residential, we have a mixture of the two, connecting a string of modules in series in parallel with multiple other rungs. Now PV modules generate a direct current, meaning that voltage and current are constant because the flow of electrons is always in the same direction. But if we supply this type of electricity to our appliances at home, we'll have a slight problem. Basically nothing works at best, or we burn a lot of appliances at worst. This is why solar arrays have a DC to AC inverter. You see, home appliances require alternating current, or AC. Unlike direct current, in AC, the electrons alternate their directions, forwards and backwards. Don't worry if you find this complicated, I'll be doing an entire video explaining the difference between DC, AC, and how we convert one to the other very soon. So don't forget to subscribe. There are a number of ways to connect solar modules to our homes or the grid. The most basic design is something like this: an off-grid system where the modules are connected to an inverter, which feeds electricity into the home. But unless you're already asleep at sundown, like my grandmother, you kinda need electricity during the evening and nighttime. We could technically be self-sufficient by adding some battery cells to our system. Basically, during the day, the solar modules provide electricity to the home and stores the excess energy in the battery cells. And during the night, the batteries are discharged and power the home themselves. However, the ideal system would still be one where we have a grid connection. Solar modules power the home, excess energy is stored in the batteries, but when fully charged, excess power is fed and sold to the grid operator. At nighttime, the batteries are discharged to power the home, but if we need extra power, we buy from the grid. There are other variations without batteries where the generated solar power is fed directly into the grid if not used at home, and obviously at nighttime we depend fully on the grid connection. A similar system is used in utility-scale solar farms where solar arrays feed into inverters directly, or first into battery storage units and then into the inverter. This is then fed into the grid and distributed to the customers. Have you ever wondered how jet engines work or why wind turbines only have 3 blades? You can learn all about that and much more right here on the channel. Thank you very much for watching, don't forget to subscribe, and I'll see you all in the next one.